Parents and teachers know the feeling, the joy of seeing that rewarding smile revealed as the penny drops in the process of learning. It's high up there on the list of very best experiences and cannot fail to inspire further motivation to learn. Our task here is to selfishly replicate these moments, and this project is one route to achieve this aim. The bad news is that it requires work. The good news is that we are here to help at every stage along the way and chart a simple course. In this project, we're going to investigate digital and what preceded it, analog. We're going to take a very familiar object, a device that's still recognised out of context, that is both digital and analog, commonly used in game controllers, a joystick. Rather than just use it to supply output to a screen, we're going to connect it to the real world and move something. This is a servo, a small motor whose position may be closely controlled, moving an arm over 180 degrees. It's a simple basic component, but combined with others can be built into a fairly complex structure. More complex structures are beyond the scope of this project, but we provide sufficient information for the whole idea to be open-ended and the basis for unlimited scope and development. It's the look on the faces of our students once the two are successfully connected that move us to develop the project further. Both the joystick and the servo are very cheap, available from many online sources. Our controlling black box used to connect the joystick to the servo is the Arduino. Arduinos are perfect for operation in both digital and analog worlds. They too can be sourced from the Far East at a discount. Although the Arduino may not feature in the educational world as the excellent microbit and Raspberry Pis are, they have been around since 2005 and are extremely well supported. Another major benefit of the Arduino is it's supported by a very competent IDE, an integrated development environment. It's the IDE that allows us to control and program the Arduino. It is free to download, and it's available in versions that can connect PC, laptops, tablets, and even mobile phones. Versions exist that may be used with Windows, Apple, Linux, and even Android devices. It's also simple to connect a Raspberry Pi directly to an Arduino. The Arduino does not need a separate screen, keyboard, mouse, or even power supply, as this is delivered via the USB cable. Small programs called sketches are written and compiled on the host machine, and then uploaded onto the Arduino. Here they run autonomously. In fact, it's possible to disconnect an Arduino and reconnect it at a later date, when the program will reconnect automatically. It's almost magic! Having covered all the basic aspects of the hardware and software and how they interoperate, we can now move to the description of how our project is delivered. At the centre is the main workshop day. This begins with an introduction to the concept of analog and digital. Again, we resort to using familiar items by way of explanation. We use a light switch as a simple digital on-off device, a light dimmer as the analog device able to control a light bulb continuously from full on, fading to off, and back on again. The joystick is analog in nature as it's moved up and down and left to right. It also has a digital function when pressed. Each aspect of analog and digital is tested in a series of steps using the LED mounted on the Arduino board. The final step is the connection of the servo and the delight. Time is short. Once the travel times to and from your school have eaten into each end of the day and a slice taken for lunch, we are left with only a few precious moments. Preparation is therefore essential. The day is a BYOD, bring your own device. The main advantages of this is that it reduces cost, but it also ensures that all attendees can continue with their work once they return to school. The main preparation carried out before the day is the installation of the IDE onto the host devices. This involves a simple download, but we are able to help should this be needed. We believe in student-centred education. To this end, every teacher and student is offered a secure, walled garden online account inside our learning management system. Here we provide training and support, along with the opportunity for students to interact and reflect on their learning. These accounts are maintained after the main event, in the hope that support can be provided for keen students. Teachers' accounts have an administration function and even the capability to author further material and set quizzes, etc. As a final benefit, every child takes possession of their kit, a joystick, servo and Arduino, in the hope that this will stimulate further investigation. We are keen to promote any ongoing activity and help with STEM and Code Club activities, and look forward to meeting you.